Hi, this is Alexi Karve. Today I'll be demonstrating the execution of MicroShift on Rocky Linux. Specifically, I'll be demonstrating the creation of virtual machines and the containerized data importer so that we can create data volumes and run the virtual machines using the persistent volumes that are cloned from these data volumes. So what I have done right now is I have started MicroShift. So you can see over here that MicroShift is currently still starting. There are a couple of pods that still need to be started, but I am currently on Rocky Linux. You can see over here the OS release. It's Blue Onyx. And what I did was I cleaned it up and then I started MicroShift. And there is a problem where it will give you some kind of 503 errors first time you try to start MicroShift. So you just go and restart MicroShift. And once it is restarted, the pods will start. So we'll give it a minute until the pods start up. And once the ingress and DNS pods are also running, we will start the containerized data importer. So we are going to do three things today. One is we'll be installing the containerized data importer. We'll also be installing the virtualization. So we need to create certain VMs. So we will install the KubeVirt operator and we will also install the OKD console. So these are three things we are going to do today. So we'll start by installing the CDI. You don't have to install the KubeVirt operator first. You can install the CDI first. If you just want to, let's say, upload the image, you can do that just with the CDI. You don't need KubeVirt for that. But to run virtual machines, you will need the KubeVirt operator. So we'll just do it in this order where we'll run the CDI first. So to run the CDI itself, we need one fix in the MicroShift image. And that fix I have already put in this current image where the request header allowed names, I had to keep it blank. And I have shown in this blog how to compile the code with those changes. So this is the change that is required. And then you can build it. And I have done this right now. What I'm going to do now is I'm going to install this ARM version. Since I want to install this version, what I do is I download the YAML files for the 1.55.2 version. That was the latest version when I was writing this blog. But we still need the ARM version. This particular version, if you try to download the binaries from there, you will not get the ARM version. So what I do is I replace the images where this version 1.55.2 is replaced with the ARM version for the images. So that is the only change that is required. So I'm going to start this install. As you can see, MicroShift is started now. And you can see the kubeconfig is configured. Okay, CDI has been created. And we can see the CDI operator is being created. Once the CDI operator is created, that in turn will create a couple of more pods. Those pods are created by this CDI CR. So right now it's this operator that is being started. So once the operator is started, then this CDI CR will allow it to create 3 more pods that are required for the import. So as you can see now, the CDI operator is running. We'll give it another minute so that the 3 other pods will get started in the CDI namespace. The API server is being started. This API server is the one that would have given an error if we don't have that fix. So while this is being started, I'll go to this folder and I will download some of the images. We need to update this annotation so that it will point to the correct node name. And what we're going to do is download the image from this location. Okay, the CentOS stream generic cloud image, that is the one we want to download and create a new data volume. So that is what we are going to do. Okay, so all of these are running, so we should be able to do that. What I will do is I will also show you the CRDs that have been created for this. So if we do the OC get API resources, you can see that the CDI API and the CDI API over here, both of them are showing true. So this one and even alpha one are both present. And if we do the API resources, then we can see that all these resources are available. Now what we'll do is we'll start the cloning. We'll apply this data volume, which will actually create the persistent volume and clone it. This process will actually start the cloning. While it is doing the cloning, we will also update the VM that we want to create. So the VM is going to clone from this particular CentOS 9 data volume, or actually the persistent volume that is created. So what we want to do is to allow it to clone, we want to change this also to rocky.example.com so that it will clone to a new volume that is created for this instance. We will not look at the VM and VMI right now because we have not installed KubeVirt, but we should be able to watch the data volume. So as you can see right now, the import has been scheduled. The persistent volume claim has been bound, and it is still creating the importer for importing the volume. Okay, so import has been scheduled. So we'll have to wait for a few minutes until the import actually starts, and you'll see the progress go up. Now that this pod is started, it will actually start the import. So it will take a few minutes until that import is completed. And once the import is completed, then we should be able to create this VM. The VM itself will actually clone from this particular CentOS 9 DV, which is the persistent volume. Okay, and then it will create another volume, and that is the volume that will be used for actually executing the VM. So this CentOS 9 DV will become the source VM. So you can create as many VMs as you want later, and this CentOS 9 DV will be the source for another import that will start when the VM is started. But while this is continuing now, what I will do is we want to start the VM. So I'm going to install the KubeVirt. Let me go back over here. So this is going to create the KubeVirt operator. And once the operator is created, then it will create the custom resource that will actually create the additional pods that are required for installing KubeVirt. You can see the KubeVirt is being created right now. So it's creating that container. So it will have to download those images. And once the images are downloaded, it will create these particular pods. And there will be more pods that will be created in the KubeVirt namespace. What I will also do is start the console install. So the OKD console is over here. So this is the token we want to use. So we'll replace the token that is in this YAML file with this new token. And then we will apply that. So there are three things going on right now. One is the CentOS image is being imported, the KubeVirt is being installed, and the console, the OKD Web console is being installed. You can see now this container is being created for the console. Why the KubeVirt is not yet done. After the operator starts, there are more things that need to be done. So it is going to proceed. It will still create few more containers in that. So while it is doing that, let's also check how far the image import has completed. So image import is at 26% right now. We'll let it run for some more time so that the import is completed. It will go up to 100%. And once the import is completed, by then, hopefully the console is also installed and the KubeVirt operator is also installed. And then we should be able to create the VMIs and VMs. So this is the CentOS image that we are currently importing directly using YAML. We can also use the image upload command if you want. And if you want to use the image upload command manually using the OC image upload, then we'll have to actually first download the image locally over here. So I'll start that process also. I'm going to download one of the images. Let's download the Ubuntu image. So let's go down and we'll go back to CDI and we'll download one of the images over here. So this is one of the images. I will download that. The Jammy server cloud image. To upload this image, we are going to require a data volume. Okay, so we are also going to create this particular data volume. Again, as usual, we'll have to update it with the proper MicroShift node name, which is in our case rocky.example.com. So we'll do that. And once we apply that, two persistent volume claims will be created. One is a scratch persistent volume that is used for processing the image that we are uploading. And the second one is where the target is, where the actual image will be saved. And then the same process will be there, as in the previous case. where once the image is actually uploaded to that, that is the source for the volumes of that are required for the virtual machines. So we can create multiple virtual machines with that as the source. It will clone from that source to the virtual machine. Okay, that is how it always works. So once this is completed, I will edit this file, and this example upload dv, this data volume is what I'm going to use for uploading this Jammy server cloud image. So let's edit this file, and instead of microshift.example.com, I will change it to rocky.example.com. I will apply this YAML file. And now you will see this example upload dv with the upload scheduled over here. And you can see the example upload dv scratch and the example upload dv. Okay, so there are two persistent volumes that have been created for this data volume. Once this container is created, then we can start the upload. So this is the upload container that will be required so that we can run the import image command. Just like this importer was present, which is currently importing the image for CentOS, which is currently at 41.35%. Similarly, we will also start the image upload process using the CDI upload example upload dv. This pod, once it gets created, we will be able to start that import also. So we'll be starting two imports simultaneously. One is already in progress, one we still have to start. So I'm showing you two different ways to run the import. One is using the command line and one is using the YAML. The one in YAML is already in progress. The one in command line is the one that we are going to start now once the container is created. We can see this pod is running. So we should be able to start the second import now. The upload is ready over here. So we'll run this virtctl image upload. And we need to run it with the dash insecure. If you don't give that, then we'll get this error. But we need to add the IP address to etc host first. We'll do that. We already have the IP address of this Raspberry Pi over here, which is with the name Rocky or rocky.example.com. We'll also add the CDI upload proxy to that. And now we can run this command to upload. Before we start the upload, let's look if all the operators are started. You can see the virt controller pods are still starting. So this virt handler and the controller, they are still in progress. So until these start, we can't really create the virtual machine, but we should be able to start the upload right now. So I will do that. I will start the image upload. First, we'll have to download virtctl. Let's do that. So I've already created a binary in one of the images at docker.io. So I'm just going to download that. This will take a couple of minutes. So all this is documented in this particular blog if you want to try it out. This is part number 28 of this particular blog series. And there are numerous samples that have been mentioned over here for using the SenseHat. Checking the temperature, pressure, humidity. If you look at all these samples over here, you can see one of the samples is for InfluxDB, Telegraph, Grafana. And there are previous recordings that you can watch for these particular demos. There is a Node-RED live data dashboard, which will show you the SenseHat sensor charts. There's a TensorFlow Lite Python example, which will be able to detect objects and show the pictures on Node-RED. And then there is this virtual machine instances on MicroShift. So this is the part that we just executed to create the KubeVirt operator and the OKD Web console, which was just installed. I'm not creating VMs directly for the Fedora over here, or the other image that I had created was for CentOS. So I've shown instructions how to just do a CRI-CTL pull and directly create the VMI over here. But I'm going to use the CDI. So those are the examples I'm showing. So with CDI, I'm going to show a couple of examples. One is the CentOS and the other is the Ubuntu. Now we have this virtctl downloaded, and we should be able to run the image upload command for that. We can see this CDI upload proxy has completed uploading the data, and now that the upload is completed, it is going to do the import. So we'll allow that to complete. Meanwhile, we can see that the CentOS image has been imported up to 83%. We have to wait till it goes to 100%. And the Ubuntu image, once that completes uploading, then the scratch will get removed. Okay, then only this one persistent volume, which is the example upload DV, that's the only one that will remain once the import for the second image is completed. So as you can see, the Jammy server image was completed. And once it was completed, you can see that that data volume is gone, and only this persistent volume is now remaining over here. And soon this import will also get completed and the data volume will be removed. And both these data volumes will be available for creating VMs. That's it. Okay, so now we have just the two data volumes which we can use for creating VMs. These are acting as sources for the VMs that we want to create. So Let's look at the pods once again. And you can see everything is running. Okay, so all the KubeVirt pods are created. KubeVirt is started properly. The console is started in the kube system namespace. And of course, the CDI was already started before. Okay, so we have everything that we need to start the VMs now. So let's start that process. So first we will create the CentOS VM. We'll apply this. And the second thing we want to do is start the VM for the Ubuntu Jammy. So we'll also have to change the node name in this one. I updated it to Rocky. And before applying that, let's just see, what is happening so we can understand. So you can see another clone is progress. So what this clone is now doing is, in order to create a new VM instance, it is cloning from the CentOS 9 DV, okay, that we had just originally created. So from this CentOS 9 DV, it is going to create a new persistent volume for CentOS 9 instance 1, and that is in this persistent volume. Okay, so this data volume is going to allow it to do the second clone. And once the clone is created, then this persistent volume will be used to create the VM. And right now, what we are going to do now is start the second one. So we'll apply this and we'll wait for both the VMs to start. So you can see the second one for the Ubuntu clone is scheduled and it should start soon enough. For cloning that one, now this pod is being started, and once it goes to running, which it has, this cloning will start. So you can see the clone for both of them is currently in progress. Since the console is already started, what we can do is we can go to the console and see what the VMs look like right now. As you can see, this virtualization has been added to the console, and we can look at the virtual machines. And you can see that the importing is still in progress in the UI. So we can see the output of top. As you can see, the CPUs are fully utilized, and there is also a lot of wait states. So basically what it is doing is it's using tar and CDI cloner to copy the files from one persistent volume to the other, and two of them are going on simultaneously. We can see now that the CentOS 9 clone was completed and the VM is now starting. So the virtual machine instance is currently being scheduled. And the Ubuntu Jammy, that was the second upload that we had started, that is still in clone in progress state. While the virtual machine instance is starting, we can connect to the console and see as it boots up. You can see that the second VM is also starting now. The clone for that was also completed. Let's click on the second one now. We're already watching the console for this. virtctl console command. Let's look at this one also in the UI. You can see the Ubuntu VM is also being booted now. Okay, so CentOS 9 instance 1 is now started. So let's log in to this. and we are logged in. You can see that it is the CentOS Stream 9 image, and we should be able to ping. Okay, so we can see that the CentOS image is working fine. The Ubuntu Jammy image is also created, and we should be able to log into that. Okay, now it worked. We can, of course, stop and start the VMs directly from here. We can go to Actions, and we can say stop the VM. You can see it's currently stopping. You can see Ubuntu VM is stopped. We can also go and start it from here. Or we can, of course, give virtctl commands directly, but I will just start it from here. While this is starting up, if we want, we can delete the VMs, like the CentOS VM which was there. So I can go and delete this VM. When the VM gets deleted, its corresponding pod got deleted, and the virtual machine and the virtual machine instance got deleted. Okay, and the cloned persistent volume which was there for CentOS instance 1, that also got deleted. Okay, so we are only left with the original volume that we used for cloning. The second volume that was there for the instance itself, that got deleted. We look at the UI. You can see that the CentOS is deleted now. Only Ubuntu Jammy is running, which we had just started. And if you look at the console over here, we'll be able to see that it should be booting. We can also connect to this from virtctl console. And you can see that it is started booting up now. And it is booting up. Once it finishes booting up, we should be able to log in again and use the virtual machine. When we are done, we can delete it exactly the same way by doing a delete for that YAML file, and the VM will be deleted along with its persistent volume and the virtual machine instance, of course. So this is all I wanted to show in this demo. Everything that you require to use CDI is in this blog, along with numerous other examples. Have fun. Thank you for watching. Bye.